Hello and welcome to this Unity tutorial on basic movement. Here I'm going to show you how to make a simple Flappy Bird style controller. We're going to work with keyboard input and we're going to make a little enemy that is moving up and down. So in the end we're going to have the bird that can jump if I press the spacebar, and otherwise it's going to fall down, and a little bird or hornet thing that is moving up and down. It's going to be our enemy. Let's start by making the side view Flappy Bird style controller and write a script for the bird to move to the right. Let's start by making the script. So I go to my scripts folder, say create C# script. I'm just gonna call this bird and then open that so I can edit it. And we're gonna add a speed variable for the bird to set a movement speed. So that would be a public float speed. Delete the initial comments here, they're just in the way. And in update we can say transform position plus equals a new vector 3, and then we can take our speed, multiply that by time.delta time to make sure that we move at a constant speed no matter what frame rate we have, and put 0 for x and for y and for z. Two things you might be wondering about here is why, if we only want to modify the x parameter, don't we just write transform position.x plus equals speed multiplied with time.delta time. If I do this, you can see that I get an error here that says cannot modify the return value of transform.position because it is not a variable. So the position value of transform looks like a variable, but actually it is a set of getter and setter functions that hide a complex set of algorithms behind it. So if I set position, actually, Unity recalculates the transformation metrics of the model and rearranges some of the inner workings of the engine that concern the position calculations for the game object. And that is why we cannot set an individual value, because this kind of complex functions are hidden behind a setter function for position. So we can only set the position as a vector 3 as a whole, but not its individual components. And the next thing is that why do we use a vector 3 if we are only in 2D? Well, Unity is a 3D engine, and the 2D version of it is just an addition that simply doesn't use the z-axis. So we're kind of using a 3D engine to make a 2D game. It still works perfectly fine, and most of the calculations and things will work just as well in 2D as in 3D. But always keep in mind that technically we are in 3D and not in 2D. So if I were to make this vector 2 and just delete the z component, it will of course complain and say, oh wait, you can't do plus equal operator between type vector 3 and type vector 2. That doesn't work. So we're just gonna slap in a 0 everywhere for the z component. So long story short, we now have a bird that can move to the right at a constant speed. But because we want to make a Flappy Bird style controller, we also need to have gravity to accelerate the bird downwards constantly. And then we need to have a vertical speed to keep track of this speed that the bird has downwards. And we need to have a value that we push the speed upwards when we press the spacebar. So let's add some variables for that. First of all, a public variable for gravity, then a public variable for the up force. That would be the speed that we have when we press the spacebar upwards. And we need a private float for our vertical speed to keep track of how fast we are moving downwards. I don't need to set these with values yet. We can set the public variables later, and vertical speed we can simply initialize with 0 here. Alright, now in update it will make sense for us to create a local variable movement of type vector3 to assemble the movement that we now need to do before we apply it to transform.position. So movement.x, we already know this is going to be speed multiplied by time.delta time. And we could rename speed here just for consistency's sake into horizontal speed. Since we have vertical speed, now that would be the horizontal speed. Alright, and transform.position will now just plus equal movement. To get the vertical speed going, first of all, we want to increase it every frame by gravity. So vertical speed would plus equal gravity multiplied by time.delta time. And then our movement dot y, so the vertical movement, would be vertical speed multiplied by time.delta time again. Now you can maybe also see that acceleration, right, that would be meters over a second squared. So we multiply it twice by time.delta time to do the accelerated downwards movement. Now here's a good place to note that in Unity the y-axis starts at the bottom and goes upwards, which is not the case in other game engines always. So sometimes the y-axis positive values also go downwards. Now because our gravity probably we want to put a positive value here. If we would accelerate like this, we would actually accelerate upwards. So it might make sense to, instead of putting a negative gravity, just subtracting the gravity acceleration. So let's try this out. I will go back to Unity, go to my bird, put my bird script on it, and put some values in here. They are all 0 because I didn't initialize them in the script yet. Gravity maybe 10. Press play and see what happens. Great, our bird moves to the right and falls out of the sky just like we wanted. The last part of the bird movement now would be to set the vertical speed to our up force if we press the spacebar. For this we will need to check for input, and input is handled by the input class. And here we can either check for keys, mouse input, or buttons. The difference between keys and buttons is that a button uses Unity's input manager that can pipe input from different kinds of controllers or the keyboard into buttons. So you could use an Xbox controller or you could use the keyboard. And you would have to set these buttons up, of course, to know which kind of keys and which kind of controller buttons map to which kind of input. Or we can simply use keys, which is a lot easier for us now. So let's do that. Just take the getKeyDown function, which returns true in the one frame where a button or a key, excuse me, changes state from not being pressed to being pressed. And we want to check for the spacebar. So we get the space key code in here, and now this if statement will be executed in the one frame where the spacebar changes state from not being pressed to being pressed. So here we simply set the movement.y to up force. Oh, up force, there we go. Okay, and now when we press the spacebar, the vertical movement is gonna be reset to our upwards. So we just have to set our vertical speed to be up force. And then of course move the movement assignment below, so make sure that the spacebar is recognized before we assign the movement parameters. And then we have to plug in some kind of value here for up force. Let's try 8. And now if I had press play and I press the spacebar, our bird jumps like we want. Perfect. Let us next program a small enemy that just simply moves up and down. For that I got this hornet here. We're gonna put this here and it's gonna move up and down a certain range. So we're gonna have some automated movement going on. So let's make a new script, create C# script, and I'm gonna call that hornet. Go ahead and open that. And in here, we first gonna delete the annoying default comments and create our variables. We're gonna need speed to see how fast we move up and down. It should be a float. Then we need float range, which is the distance that we want to move from our starting position. And we also need the starting position saved, so we can compare how far away we are from the starting position and see if we have to switch the movement direction. Now the start function is executed the moment that either the game object with the script attached to it enters the scene, or when the scene starts and the game object already exists in it. And here we have to see that our start position is saved, so we can later compare our actual position to where we started to see if we are out of the movement range and have to switch direction. This movement direction we can keep track of as a private variable, an integer, and we can initialize that with 1, and then we're just going to switch that to -1 if we move downwards. So we can calculate our movement by setting transform.position, rather adding a new vector 3 to it. And we want to add a vector which has 0 and x, because we don't move left or right now, we only move up and down. And then for the y, we want to multiply the speed with time.delta time, as we are used to. And then we also multiply direction on top of it, so we can change positive or negative movement, and simply plug in 0.0 here for the z component again. There we go. Now we can move vertically. And lastly, we just need to check if our transform.position.y would be bigger than the start position.y plus range. So if we are too far up, we have to switch the direction to be negative. And similarly now, if we are too far down, so if our position is smaller than transform start position minus range, we have to move upwards instead. Okay, wait to compile, and now on the Hornet we add the Hornet script. We have to plug in something for speed and range, so let's put some values in here and see our Hornet move up and down. Great. Now we have an enemy, and we're gonna handle collisions with it in the next video.